Anybody just have any general questions about anything before we get going?
So if we decide.
Right, yeah. Yeah, it's just, you just come the day next week when you want to take the test. Anything else? All right, we'll look at the practice test then. It's mostly hypothesis testing. That's been kind of our focus. But do have a little bit of the chapter 12 at the end. I don't know. Somehow I erased like the directions on these first few. It's just supposed to say find hypotheses on 1 through 3. So I just wrote in a blank for us there. Okay. 1 says a newsletter publisher believes that more than 79% of their readers own a personal computer. That's really the only part we need to focus on. So the claim that we would test here is that more than 79% own a personal computer. And since it's a percentage, it's a proportion. And so our symbol would be P. And our claim is that that is more than 79% or 0.79. And then for the null hypothesis, we would use equal to 0.79. Questions on that one? Yeah, the percentages are P's. And then if they're, sometimes I don't spell it out if it's a mean, but the other ones are mean, so you use the mu. So it looks like we'll have P again on number 2. It says a newsletter publisher believes 29% of their readers own a laptop. This one's worded a little different. It says, is there sufficient evidence at the 0.05 level to refute the publisher's claims? That means to prove them wrong. So the publisher here thinks that P is 29%. So if that's the part you're picking up on first, that would be that P equals 29%. And since that has equals in there, that has to be the null hypothesis. So if that's the part you see first, then you'll see the null hypothesis is 0.29. Okay. Or you could think about the question it's asking, is there sufficient evidence to refute the claim to say that they're wrong? So if they think it equals 29%, but they're wrong, we're refuting that. What's that mean? Our alternative is going to be that P is not equal to, because it doesn't say more, doesn't say less. So it would be not equal to 29% on that one. And on the test, I don't care if you write it as a decimal or a percentage, you can do it either way. Question on that one. That one's a little weirder because you may have seen the null hypothesis first. Okay. 3 is an engineer's designed a valve that will regulate water pressure on an automobile engine. The valve was tested on 180 engines and the mean pressure was 6.1 pounds per square inch. Assume the standard deviation is known to be 0.6. If the valve was designed to produce a mean pressure of 6.2 pounds per square inch, is there sufficient evidence at the 0.02 level that the valve performs below the specifications? So really all we need is the stuff at the end. It says it was designed for a mean pressure of 6.2, and is there evidence that it performs below the specifications? Here we're dealing with means. So our alternative hypothesis would be that mu is less than, because it says below. And then the number it's supposed to be is 6.2. So then our null hypothesis would be mu equals 6.2. Questions on those? We're just focusing on getting the hypotheses. Okay. They're not too bad once you get the hang of them. Number 4 says a newsletter publisher believes that over 64% of their readers own a Rolls Royce. For marketing purposes, a potential advertiser wants to confirm this claim. After performing a hypothesis test at the 0.01 level of significance, the advertiser failed to reject the null hypothesis. So if they failed to reject the null hypothesis, what does that mean about our claim? Does that mean we had evidence to support it, or we did not have evidence to support it? If we fail to reject the null hypothesis. If we fail to reject the null hypothesis, does that mean we had evidence or did not have evidence? It means we did not have enough evidence to support the claim. That's when we failed to reject the null hypothesis. So this one's B. There's not sufficient evidence to support the claim. And this matches with when we reject the null hypothesis. If we do have strong enough evidence to support the claim, that's when we reject the null hypothesis. And I won't try to do anything tricky in there. Anything. If you see fail to reject, that means there's not enough evidence. If you see rejected, that means there was enough evidence. Questions on that one? Okay. Got another water pressure valve. Says the valve was tested on 200 engines and the mean pressure was 4.2 pounds per square inch. Assume the population standard deviation is 1.0. If the valve was designed to produce a mean pressure of 4.1 psi, is there sufficient evidence at the 0.02 level that the valve performs above the specifications? Okay. So this one we're going through the whole hypothesis test, and we got step by step laid out. So for our hypotheses, our alternative hypothesis, the claim that we're trying to test, is that it performs above the specification. That means that mu should be greater than some number. It says it was designed to produce a mean pressure of 4.1. So if it's above the specifications, that means it's greater than 4.1 psi. And the null hypothesis, mu equals 4.1. I'll have answer boxes on the test for you so you can. Yep. This one's not too bad because it says mean. So that's going to be mu. If the number it's giving you is not a percentage, you're going to use mu. Other questions on that part? Okay. 2, just find the value of the test statistic. I will help out on test day. Okay. On the test, it will either say find the value of the Z test statistic or value of the T test statistic. I'll help you with figuring out which formula to use. Okay. Here, we can figure it out, okay, because it gives us population standard deviation. So that means sigma is known. That means we're going to use a Z. In our formula, Z when we're dealing with means is this. We really don't need that first sentence, so I'll scroll up a little bit more. Okay, so we already know one of the numbers. because we've got the hypotheses, we know that for mu, we're going to use 4.1. The other numbers, we look back at our problem. It says the valve was tested on 200 engines. That's going to be N. Of those, the mean was 4.2, so that's our sample mean, X bar. And then it says assume the population standard deviation is 1.0. So we'll get 4.2, our X bar, 1.0 is our standard deviation, and then square root of 200. We're going to round to 2 decimal places on these. So let's see. I get 1.41. Questions on filling in the formula? Okay. Step 3, I will be slightly more specific on test A, which I mentioned earlier. Okay. Hawk's always asked, is it one-tailed or two-tailed? I'm going to ask, is it left-tailed, right-tailed, or two-tailed? Because you got to figure that out anyway. So this one, it is one-tailed. We want to be more specific than that. Is it left-tailed or right-tailed? This one's right-tailed, because then our alternative greater than points to the right, so this is right-tailed. Step number 4, let's find the p-value. So of our test statistics, so we're using our previous 2 answers. Okay. We know our test statistics 1.41. We said it's right-tailed. So for our p-value, we want the area to the right of our test statistic, which was 1.41. So to get the area to the right, we're going to look up the opposite. So we'll look up negative 1.41 and get 0.0793, I believe. Okay. Step 5, we want the level of significance, so we just look back at our problem. So it says, is there evidence at the 0.02 level? Okay, so nothing else to calculate or anything there. We're just taking note. Our significance level alpha 0.02. And then we need to make our decision. So remember, we compare our p-value with alpha, the significance. So how does that play out? Our p-value is bigger than, greater than alpha. So what's our conclusion? Yeah, if our p-value is too big, we fail to reject the null hypothesis. If our p-value is low, that's when we reject the null hypothesis. If our p-value is smaller than or equal to alpha. Questions on any of those steps? Okay. All right then. That's one down. One down. Number 6, we got a little wordier here. If you skip down to the bottom, it just all we're looking for is the value of the test statistic on this one. We don't have to do the whole hypothesis test. So let's see, it says the valve was tested on 270 engines. The mean pressure was 6 pounds per square inch. Assuming population standard deviation is 0.6. Designed the valve so it produced 6.1 psi. That's really all we need to find the test statistic. Again, it says population standard deviation, so sigma is known. So this will be a z, just like the last one. So write down as much of the normal process as you need to. If you want to write down the hypotheses first, please do that. To make sure you get the right number from mu. And so if we were writing down the hypotheses, we want to look at the pressure it was designed for, and it says the engineer designed the valve so it would get a mean pressure of 6.1. And so that's going to be our mu. And then filling in the other numbers from our sample data. Said the mean pressure was 6. 6 bar. Population standard deviation was 0.6. And then our sample size on this one is 270. So if you can do the last one, you shouldn't have any problems with this one. It's just we don't have all the step by step with this one. Oop, I hit some kind of. So this one I get negative 2.7 rounds to 4. It's negative 2.7. Questions on that one? It's just like step 2 of the last one. Okay. All right, again, this is just a piece of a hypothesis test. This one just says find the p-value. This one's a little bit more involved because that's one extra step. Right? We got 2 things we have to know to find the p-value. We got to have the test statistic, and then we need to know what type of test we're doing. Is it left-tailed, right-tailed, or two-tailed? So on this one, it's probably not a bad idea to write down at least the alternative hypothesis. So let's see. Skimming down through here, it says the engineer designed the valve such that it would produce a mean pressure of 7.9 psi. It is believed the valve does not perform to the specifications. It doesn't say above or below. So it's supposed to be 7.9. We're thinking it's not 7.9. Doesn't say above or below. So what's our symbol going to be? It's not equal. Yeah, not equal to. Okay, so this one is two-tailed. It's two-tailed. Yep. And then the other thing we need is the test statistic. This one throws us a little bit of a curve. It gives us variance. But on this particular one, if you didn't notice, it wouldn't matter because you get, so it's given us sigma squared. But all I have to do to get sigma, take the square root of that. And the square root of 1 is still 1. So it wouldn't mess you up on this one. So, oops, sorry. So Z, let's see, the valve was tested on 200 engines and the mean pressure was 7.8. Minus our number in the hypothesis, 7.9. Over our standard deviation, which is 1. Over the square root of the sample size, which is 200. So that's going to come out. I'm kind of getting crammed in here, sorry. Negative 1.41. So remember, it was two-tailed, so we're not just concerned about one tail. We are concerned about the negative 1.41, but we're also concerned about positive 1.41. And we want the area in both of those tails. So to get our p-value, we're going to do 2 times one of the tails. And the easiest one to look up is the negative one. So if we look up negative 1.41, which I think was the same we had earlier, 0.0793. Okay, so 2 times that. Get a total p-value of 0.1586. That's the hardest p-value to find. You have to remember to do 2 times the p-value when it's two-tailed. So two-tailed, we multiply by 2. Questions on that one? Okay. Number 8. Another hypothesis test. This one's a different type. Okay, this time I got a banana chip bag filling machine. They want to know if it works correctly at the 445 gram setting. And then we got our sample data. It says, is there sufficient evidence at the 0.025 level that the bags are underfilled? So for our hypotheses on this one, and for our alternative, we're dealing with a mean again. We want to know if they're underfilled, so that's going to be less than some number. And the number is less than, it says the setting is 445 grams, so we're going to be less than 445. And our null hypothesis will be that mu is equal to 445. Two says find the value of the test statistic. This one, I would say find the value of the t's test statistic, but up here I will also put sigma as unknown, like I did with the confidence intervals, to help make sure you see it's t. This one gives us variance again. So what this one's giving us is S squared is 441. So S, we would take the square root of that. So our standard deviation is 21. I'm not going to give you variance on the test. These are just randomized out of Hawks, and sometimes they throw variance in. So for a t-test statistic, formula looks almost the same. We're just calling our standard deviation S instead of sigma. So let's see. This is based on a 12-bag sample where the mean is 441. Minus the number in our hypotheses, 445, divided by our standard deviation, which is 21, over square root of the sample size, which is 12. And since this one's a t, we're going to round to 3 decimal places. It tells us that. Here I get negative 0. Okay, so it's negative 0.69, I don't know, 6598 something. So when we round to 3 places, this is one that's a little tricky to round. The 9 rounds up to a 10, so we have to carry the 1, so it'll be negative 0.660. Step 3 says, what kind of test is it? One-tailed or two-tailed? We're going to go a little bit further than that. So if we look at our alternative hypothesis, we're left-tailed, right-tailed, or two-tailed? Yeah, less than points to the left. So we are one-tailed, but more than that, we're left-tailed. And then since it's t, we're not finding a p-value. It's asking us to determine the decision rule, or another way of saying that is we want our critical t-value for the rejection region. And so we're going to need 2 pieces of information here. We're going to need degrees of freedom. I get that by taking n-1. And then we need the area in the tail. That's going to be our significance level. So our sample size was 12. So we'll have 11 degrees of freedom. And then our significance level, what did it say? Is there evidence at the 0.025 level? So we want an alpha of 0.025, or area in one tail, 0.025. So we'll go to table C to look up our critical t-value. And we have 11 degrees of freedom, 0.025 in one tail, that's the middle column. So we get 2.201. Well, we gotta remember one other thing on this one. Which tail are we dealing with, left or right? Left, so what else do we have to remember? It gotta be negative, yeah. The right tail, do you just leave it positive? Left tail, do you make it negative? Okay. Then that's everything we need. We can make a little sketch if we want to. So here's our critical value, negative 2.201. Our test stat falls to the left of that. We reject the null hypothesis. If we look back at our test statistic, it was negative 0.660, which is not far enough to the left. So what's our conclusion? Our test stat was not in the rejection region, so we failed to reject the null hypothesis. Questions on that one? And it's a little different because we have the rejection regions. Okay. All right, then next, we got number 9. Time it says a publisher reports that 56% of their readers own a particular make of car. We're dealing with a percentage here, so we're dealing with proportions. Marketing executive wants to test the claim that the percentage is actually more than the reported percentage. Okay. Is there sufficient evidence at the 0.05 level to support the executive's claim? So the claim here, HA, is that our proportion P is more than, greater than, the claimed number, and the claimed number was 56%. That number. So H0 be that P equals 56%. And again, I don't care if you write these as decimals or percents on the test, but when you go to use it in the formula, you got to change it to a decimal. Or it's easier if you do. Two, we're dealing with proportions. We only have one formula for proportions, so that narrows that down for us. And then our formula is P hat minus P over the square root P times 1 minus P over N. Again, don't remember, I'll give you a formula sheet with all that. So we can already fill out most of our formula. We've got 0.56 for P. We just need P hat, and we need N. P hat we may have to calculate, or it might give it to us. Let's see what it does. It's a random sample of 200, so that is N. Found that 62% of the readers owned a particular make of car, so that this time it just gives us P hat. It could have alternatively said something like 124 out of 200 people in the sample own a particular make of car, and then we do X over N, right? That would give us 0.62. So filling into our formula, we got 0.62, and then our sample size was 200. These are Z's, so we'll round to 2 places. So let's see, I get 1.71 after we round. That's 1.709. Have questions using that formula? Okay. Step number 3. This is it one-tailed or two-tailed? So let's look back at our hypotheses. What kind of test is this one? Is it left, right, or two-tailed? This one's a right-tailed. Greater than points to the right. So we're dealing with a one-tailed or right-tailed test. Step 4 wants the p-value. So we want, since it's right-tailed, we want the area to the right of our test statistic. Our test statistic was 1.71. So to get the area to the right, we can look up the opposite. Got negative 1.71. Let's see. I get 0.0436. P-value. Step 5 wants us to put down the level of significance. So this one just says 0.05 level. Alpha is 0.05. Step 6 says make the decision. So what's our situation this time? Yeah, p-value is smaller than alpha by a little bit. So we reject the null hypothesis. And then this one gives us one more. It says, okay, so since we rejected the null hypothesis, what does that mean about our claim? Does that mean there was sufficient evidence to support the claim, alternative hypothesis, or was there not sufficient evidence? There is. We rejected the null hypothesis because there was enough evidence in our data to reject the null hypothesis. So that means we have support for the alternative hypothesis, which is that the more than 56%. Yep. Yeah, and if our p-value is small enough, if it's smaller than the significance, we reject the null hypothesis. If it's bigger, we fail to reject. Yep. Okay. Any questions on that one? All right. Number 10, we're on chapter 12 stuff. I'm not going to make you plot out a scatter plot, so don't worry about that step. And it's just plotting points. Don't worry about that one. We got our table of data here. Step 2 is estimate the correlation in words, positive, negative, or no correlation. They're in order, right? So what's it look like as our hours spent studying go up? What generally happens with their midterm grades, they go up. So what type of relationship is that? Is that positive, negative, or no correlation? Positive. If they go the same direction, both go up or both go down, that's positive. If they go opposite directions, that's negative, or if they're not related, that's no correlation. All right, and then step 3, just calculate the correlation coefficient. That's what we worked on last time, R. Right, around the 3 decimal places. That's just a calculator question, right, where we're putting, it is in rows here, we're putting hours spent in for X, midterm grades for Y. really on correlation, it doesn't even matter if you get those backward, you'll get the same answer. So I'll write it right here if you're trying to practice. So for R on this one, you get something that rounds to 0.997. So if you don't have a calculator that'll do that, you need to get one or borrow one or something, okay? And then practice a little bit with it. Make sure you know how to get R out of it. Well, it's just a calculator problem. And we can kind of check ourselves a little bit. It won't help us necessarily with just like a little typo or something, but because we said we expect there to be a positive correlation, so we expect our R to be positive. If we had negative correlation, we would expect R to be negative. And then, so that was, what was it, 0.997. That's it on that one. For 11, and give this first test scores and second test scores for a chemistry class. It says find an equation of the least squares regression line. I'll put the formula on the formula sheet. So I'll give you this. We just need to plug in for the slope and the y-intercept. So, yeah, and I'll try to give you shorter data sets too. So we just put our numbers in just like we did for correlation coefficient. But this time, instead of going to R, most of your calculators call these two numbers A and B. You just need to know which one goes in the right place. On this one, our equation, and for the y-intercept, you should get something that rounds to 2.607. And then for the slope, you should get something that rounds to 0.788. And the slope's the one that goes with the x. And then for the bottom part, for step 2, it says if a student scored a 78 on his first test, make a prediction for his score on the second test. So how do we do that? Remember? Yeah, we plug in 78 for x, that's right. So make our prediction, it would be 2.607 plus 0.788 times 78. And for that, let's see what we get there. Let's see, it says round to 2 decimal places if necessary, so that comes out to 64.07. See? All right, and that's it. Yeah, I'll make it clear. Yeah. Yep. Yeah, I'll help you decide between Z and T, and then I'll give you the formula sheet with all the formulas. So. The only thing with chapter 12 we'll have is this. The rest of it's in your calculator for R and A and B. All right. If you still need to sign the sign-in sheet, make sure you get on there before you head out.